All right, here we go. Chapter review. Write a function rule that gives the total cost, C of P, of pounds of sugar if each pound costs 59 cents. What did you choose for this problem? D. 59 cents. Compare A to D.
Oh, I did
Okay.
59.
You have me writing the wrong thing in the blank. D. Number 2. A snail travels at a rate of 2.37 feet per minute. Write a rule that describes the function. How far will it travel in 6 minutes?
B.
So you chose B. 2.37 times the amount of time. When you multiply that by 6, you get 14.22. So that one is B. Number 3. It says a zucchini plant in Darnell's garden was 10 centimeters tall when it was first planted. Since then, it has grown approximately a half a centimeter per day. Write a rule that describes this function. And then after how many days will it be 0.185 meters tall? So which function did you use? How tall is it at the beginning?
10 centimeters.
10 centimeters.
0.5.
Plus 0.5. Which one says that? A? Is that the only one? Does B say the same thing?
No.
B says to multiply 10 by the number of days. That would tell me that it's growing 10 centimeters a day. Is that what's happening? No, so it's not that one. C says to divide the number of days by 0.5. Is that what's? No. D has me multiplying 0.5 times the number of days. So does A. What's the difference in the two equations?
You have to add the 10.
You have to add the 10. So the only one that's going to work here is A. Now, when you do this problem, how long will it take to be this many meters? It grows this much centimeters. We're going to do some conversion. How many centimeters does it take to make a meter? 100? 100. It takes 100 centimeters to make a meter. So, this 0.185 needs to be multiplied by 100, and that is 18.5 centimeters. That's how tall we want it to be. Well, it starts out being 10 centimeters tall. So my equation says 0.5D plus 10. I want to know when that is 18.5. So I subtract the 10. And then I divide by 0.5. And what is D? 17. So answer's A. Number 4. Lena makes home deliveries of groceries for a supermarket. Her only stops after she leaves the supermarket are traffic lights and the homes where she makes the deliveries. The graph shows her distance from the store on her first trip for the day. What is the greatest possible number of stops she made at traffic lights?
3.
Well, tell me what happens here. She stopped. So I'm going to put an X there. Do we know why she stopped? No, we don't know why. What about here?
Stop.
What about here?
Stop.
What about here? How many times did she stop? 4. Why do you think only 3 of them could have been for traffic lights?
Because she stopped once that
She had to deliver some groceries, or she wouldn't even have left the store to begin with. So the maximum number of stops would have been 3. Next page, number 5. What is the domain of the function? Domain.
62. 49. 30.
Okay. And what is the range? Okay. Number 6, evaluate f of x equals negative 2x minus 7 for x is negative 1. So we're going to plug that negative 1 in place of x. F of negative 1 equals negative 2 times negative 1 minus 7. You don't do anything with this part. This is 2 minus 7, which is negative 5. So this answer is negative 5. We're going to do the same thing for this one. We're going to put it in place of the x. F of negative 3 equals negative 1/2 times negative 3. What happens when you multiply those together? 3 over 2, which is 1.5. Number 8, a taxi company charges passengers $1 for a ride, no matter how long the ride is, and an additional 35 cents for each mile traveled. Here's the rule. It describes the relationship between the number of miles and the total cost for the ride. What is the charge for a 1-mile ride? What'd you get? $1.35. Does everybody understand where I got that? Yes? What did you get for a 2.7-mile ride?
$1.75.
You have to work the function out, and it is 0.35 times 2.7 plus $1.35. I get $2.30. Is that what you got? No? Did I do something wrong? $0.35 times 2.7 miles plus the dollar. Oh, I wrote that $1. I did do something wrong. Did you get $1.95? Yes. Number 9, graph the function. How would you go about graphing that function? What would be your strategy? Make a table. From the table, we would need to make a graph. So here's number 9, and here's the table. Give me some x values that y'all want to use.
1, 2, 3.
You have to use some negatives.
-1, -2, -3.
How about this 3? What happens when you use negative 1? 3 times negative 1 minus 2. 3 times negative 1 is negative 3, negative 5. Okay. What happens when you use 0? What happens when you use 1? So then we come over here and we graph. Negative 1, 0, negative 2, 1, 1. And they line up in the line, don't they?
On the test, do we need to have a negative number? Okay, so a negative and a positive.
It might be multiple choice. You might have to pick the right graph, but you're gonna have to. So y equals absolute value of x minus 2. So here we go. Here's our chart. What do you want to use for x? We can use the same 3. So here we would have absolute value of negative 1 minus 2. What's the absolute value of negative 1?
1.
And what's 1 minus 2? Okay. So then I would have the absolute value of 0 minus 2. What's the absolute value of 0? And 0 minus 2 is? Okay. Absolute value of 1 minus 2. And 1 minus 2 is negative 1. So here we go. Negative 1, negative 1. 0, negative 2. 1, negative 1. There's our graph. Absolute value equations have V-shaped graphs. 11 says y equals negative absolute value of 3x plus 1. Same thing here. Negative 1, 0, and 1. Negative absolute value of 3 times negative 1 plus 1. What's the answer to that multiplication problem? And then when you take the absolute value, what do you get? 3. And then you have to stick the negative on the answer to the absolute value. And what does that turn it into? A negative 3. And what's negative 3 plus 1? Okay. Now we're going to use 0. What's the answer to the multiplication problem? 0. What's the absolute value of 0? What's the negative of 0? 0. 1. And then we have what's 3 times 1? And the absolute value of 3? And the negative of that plus 1, negative 2. And then we're ready to graph. What's different about this graph? It's going down. That sign right there causes it to be downward, the negative in front. That's its job. Okay, number 12, write a function rule for the table. And I want you to look across the table. What are they doing to turn 2 into 4 and 3 into 6, 4 into 8? So f of x equals 2x. Simple, simple, simple. What about the next one? That's so easy. 14. The length of a field in yards is a function of the length of n feet. Write a function rule for this situation. What do you know about feet and yards? 3 feet for 1 yard. So if you have n feet, what do you do with it to determine the number of yards? Ma'am? Okay, you have 9 feet. How many yards is that? How'd you come up with that? Okay, what if you had 15 feet? Five yards? What are you doing each time to the number of feet? Dividing it by what? 3? How many feet do you have in this problem? You don't know. What letter do they use? N. So you need to do the same process you've been doing. What have you been doing? N divided by 3. So f of n equals n divided by 3. Number 15. Crystal earns $5 per hour mowing lawns. Write a rule to describe the amount of money M earned is a function of the number of hours spent mowing lawns. So what would we write? M is the amount of money. Okay. How much does she earn if she works 2 hours and 45 minutes? What do you think about that one? M equals 5 times 2 3/4. How did you get 2 3/4? Everybody agreed that 45 minutes is 3/4 of an hour. So, what do we do here? This one? 2 3/4 times 5. I get 55 over 4. I don't want that. I want math. Math. I want a decimal because it's money, right? Oh, it says quit. Okay, I'm going to have to just do it the old-fashioned way. 55 divided by 4. $13.75. Everybody get that? Yeah? 16. Model the function rule with a table of values and a graph. So you need to do just what we've been doing on graph paper. When -1 is the x value, what's the y value? 2. When 0 is the x value, what's the y value? When 1's the x value, what's the y value? Okay, so let's graph that. -1, 2, 0, 0, 1, -2. Questions there? 17. Elaine is in the business of repairing home computers. She charges a base fee of $45 for each visit and $40 per hour for labor. The total cost for a home visit and X hours of labor is modeled by the function rule. Use the function rule to make a table of values and a graph. So what do we do?
0, 0.
Is it 0? Why? Why is it not 0? I mean, is it?
Yeah.
Okay, she charges them 45.
So it's 45. We all agree? Because if you put a 0 here, this part does go to 0. But you still have to add 45. Okay, what about 1 hour? 85. What about 2 hours? Who? How many? 125. It doesn't double. We just add another.
So it doesn't double to 45.
No, look here. 45 plus 40 times 2. The only thing that doubles is the 40. 80 plus 45 is 125. Okay? Now the next time, the only thing that gets multiplied by the 3 is the 40. Okay, so that is 45 plus 120, which is 165. So the price goes up by the same amount every time. How much? 40. Okay, so on the bottom we're going to have, this is hours. And we're going to count. We're going to do 0, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. And then on the side, I don't need to go 5, 10, 15, 20. I don't need to go 10, 20, 30, 40. I'm going to count by 20s. But I'm only going to label every other line. Like the first one's 20, but I'm not going to write it on there because it's going to get too crowded. So the next one's 40. That one's 60, then this one's 80. That one's 100, this is 120. This is 140, this is 160. This is 180, this is 200. Okay, I got that right. 0, $45. So I'm about right here. 1 hour and $85. 2 hours and 125. 3 hours and 165. So there's my graph. We good?
I think no one worked that.
Okay, well it needs to be this kind of graph. Okay? Now, we're not doing direct variation. I haven't taught that yet. We're going to do that at the end of this week. So you weren't responsible for 18, 19, or 20. Let's go to the next one. 21 is the next one you were responsible for. Label each section of the graph. What's going on? What's going on here? Speed's going
Down.
down. Then it's going up. And then it's the same. What happens right there when this... What happens right there? It's going speeding up. The speed is changing, and then it starts going the other direction, slowing down, right? So if you're going really fast, you might be going, are we skating? Oh, okay, so we're on a flat surface. So this is where you're going fast, and then you start to slow down for whatever reason. Someone's in front of you and you need to put the brakes on. Do y'all still roller skate? Have y'all ever been roller skating?
We have, if we can't anymore.
Okay.
Yeah, we used to, a lot of people would have to break that.
Never? Okay, 22. Find the range for this domain. So we're going to plug in every single number. It's probably best if you make a chart. What happens when you plug in -3 in place of x? It's negative from the problem, then a -3 plus 4. What's that going to be? That's going to be +3 plus 4 is 7. Then it's a negative from the problem, a -2 plus 4. What's that? Then it's -1 plus 4. Then it's -1 plus 4. 3. So the range is 7, 6, 5, 3. Use the vertical line test to determine whether the relation is a function. What did y'all decide about this one? Yes, it is a function. If you slide a vertical line across the graph, it will not touch two dots at the same time. So it makes it a function. If it does touch two dots at the same time, it is not a function. Sketch a graph of the speed of a city bus on a daily route and label each section. Part A, the bus pulls away from a stop and increases speed. So, something like this. That's part A. The bus is at a constant speed. So it's a flat part of the line if we're at a constant speed. The bus is stopped. Part C is it stopped. So I'm down here at the bottom. And then what does it do on the next one? Increases the speed after stopping. That's part D. Okay? Yours doesn't have to look just like mine, but it needs to be fairly consistent.